That being said, our goal for today, our main goal for today will be to find the surface area, which I abbreviate with a capital SA. I don't necessarily think that's very mathematical. That's just my own personal abbreviation. Capital V for volume. And what we're focused on today are cylinders. Surface area and volume of cylinders. Couple of terms in general that will apply to our different types of polyhedra for this unit. First of all, do you know what that is? What? What?
It says like a trapezoid prism.
Very good. Trapezoidal prism. I'm impressed. I am impressed. This is a trapezoidal prism. Not so concerned about what that actually is, but more just using this to look at different parts of it. You can see that you have a flat surface that is a polygon. That's probably a rectangle on top, but your faces of polyhedrons are all polygons. So squares, rectangles, triangles, trapezoids. An edge is where an intersection of two faces are. This is the intersection of two faces. And then finally, we have a vertex, which is where three or more edges meet. Intersection of three or more edges. What we are going to look at next are examples and non-examples of polyhedra. So we are going to take the ones that are listed and we are going to correctly place them in the chart. So with that being said, we first have a prism. Raise a number 1 finger if you think that is a polyhedron. Raise number 2 fingers if you think it is not. Everybody up, 1 or 2. Is that a polyhedron or not? Yes, it is. All of the faces are polygons, so that is a polyhedron. Pyramid, 1 is a polyhedron, 2 is not. Everybody up. 1 is a polyhedron, 2 is not. Nolan, why do you say no?
I'm not quite sure.
Well, something made you say no.
Yeah, because there's only one place.
But is it a polygon? That's really the only thing that matters.
Oh.
It is. Okay, a pyramid is. What about a cone? 1 is yes, 2 is no. Lauren, why do you say no?
It's like, it doesn't have like a vertex. Or, cause like, I don't know, like it's not like a prism, it's like round.
It's got that curved area. Right. What about a cylinder? 1 yes, 2 no. Taylor, why no?
Because, again, it has that curved area.
It has that curved surface, which we'll define a little bit better in a minute. And then finally a sphere. 1 for yes, 2 for no. Kat, why do you say no?
have any of the vertex edges or a single face.
Good. It doesn't have any polygon faces. Good. So now if we are looking again at the surface area of a cylinder, again, this is area of all of the surfaces. We have our two circles, and we have, you guys saw on the net, that circular part is really just a rectangle wrapped around. A couple of parts of cylinder, you have your two circular bases. And those bases are parallel and congruent, I should say. Parallel and congruent. Those circles are the same size. The rectangle that is wrapped around those two circular bases that connects the bases is what we call the lateral area. The lateral area. And again, we came up with this, but surface area formula of a cylinder is our 2 pi r squared plus 2 pi r h. We are just finding the surface area of each cylinder. Notice the directions say to leave your answers in terms of pi. What that means is you are not going to multiply your number by 3.14 or by your pi button in your calculator. Okay, you are going to leave pi in your answer. The reason for that is, in terms of pi, is the actual exact surface area or volume if you're looking for volume. If you multiply it by pi, you would be rounding and approximating. Okay, so it's just because it's a more exact answer. With that being said, let's start with the formula. And really the only two things that we have to know is the radius of your base and the height of the cylinder. Which, if you look at your picture, you are given both of those. The radius of the base is 6 feet. The height of the cylinder is 11 feet. So it's really just a matter of taking those values and plugging them in. So 2 pi times 6 squared plus 2 pi times 6 times 11. We need to simplify this a little bit. 6 squared, ladies and gentlemen, times 2. What is it? 72. So this first part is 72 pi plus 6 times 11 times 2. What? 132 pi. Don't forget your pi's in there. From there, now we can add. That pi really just acts like a variable. So 72 pi plus 132 pi is 204 pi. Don't forget your units. This is feet squared. It is area, so your units are still squared. Alrighty, ladies and gentlemen, surface area is 2 pi r squared plus 2 pi r h. The radius of our base is 3. The height of our cylinder is 4. When all is said and done, Bailey, what did your table get for the surface area?
42 pi.
42 pi. Don't forget your units. What are the units?
Feet.
Feet?
Yeah.
It's area. Squared. There we go. All right. Let's move on to volume again. We already looked at the net for the volume and developed that. Let's just make sure we get it into our notes again. Volume of a cylinder is pi r squared h. The area of the base times the height of the cylinder. Those are the two things that matter. Again, the only two pieces of information that we need to be able to find volume is the radius of the base and the height of the cylinder. So it's really not any more difficult or easier to find volume or surface area. It's just using a different formula. Find the volume of the cylinder. Again, notice that we are leaving our answers. We are leaving our answers in terms of pi. So start with your formula.
Would we not square it because it's not area?
So the radius of our base is 8. The height of our cylinder is 6. Make sure that you follow order of operations. Exponents come before multiplication. So we need to square 8 before we multiply it by 6. And what do we get when we do that?
64 times 6.
Which is what? 384 pi. Oops, I'm missing my 4. 384 pi, don't forget your units. This is inches cubed. I am going to be very picky on your units this unit, Artem.
Does it have to be 3?
I saw a lot of you set this up correctly. You started with your oh, hello.
That was.
I'm not sure how that happened. I have absolutely no idea how I did that.
Wait, what did you do?
I somehow got an arrow on my paper. I don't even know. No, this is not Notability.
Okay.
This is explain everything. All right, so you started with your formula.
You can't explain how you put it. That's funny.
I can explain everything but that. All right. We are given the volume. So this 4561 should be substituted for V for volume. The other thing that we are given in the problem is the height of our cylinder, which we want to substitute that 12 in for H for height. And now, ladies and gentlemen, this is not in any sort of the way a geometry problem at this point. This is 100% an algebra problem. 100% an algebra problem from here. We are solving for R. When you're solving for a variable, your goal is to get that isolated, everything else away. So what do we need to get away from that R? 12, okay. Let's divide both sides by 12. That gives me pi r squared equals what? I do not have it on my paper. 380. Okay. It's 380. Okay. What else do we need to get away from my r, Nolan? Pi. We can divide by pi. Guys, remember, that's actually like a number. That's actually a number.
Wait, how'd you do that?
So when we divide that 380 by our pi button again, what do we get? 120.96 rounded up to the hundredths place. Last thing to get r by itself, how do we undo a square? Yeah, take the square root. So r is by itself, and what is the square root of that 120.96? Yeah, this one rounds pretty nicely up to just a nice 11.